Okay, another polynomials question. This one, as you can see, we could take x cubed as a common factor. So this one is going to involve a triple root. Okay, let's see. So same thing. Let's find the x-intercept. The y-intercept is obviously going to be 0 because when x is 0, we get y 0. Okay, so let's find the x-intercept, shall we? So as a common factor, we've got 2 here and 4 here. So 2 can be a common factor, or negative 2. And then x to the 4, x to the 3. So we can take x3 as a common factor. Okay, negative 2x3. Okay, so x-intercepts make y 0. This is what we get. We factorize. I've taken negative x cubed. You could take 2x cubed. It's fine. You should get the same answer. Okay, so negative 2x cubed, brackets, that leaves me with x minus 2 is equal to 0. So negative 2x cubed is 0, or x minus 2 is 0. Right, so we get either x is 0 or x is equal to 2. Notice x cubed is 0. Okay, so there's a triple root at 0. And I want you to remember what happens when you have a triple root at a point. Think of the graph of y equals x cubed. Yeah. Okay, let's see. All right, so our two roots are 0, well, a triple root at 0 and 2. So we need to find out what's happening before 0, between 0 and 2, and for values bigger than 2. Okay, so we need to find the y values at these critical, between these critical points, okay, and less than 0 and greater than 2. All right, so let's do this. Okay, first of all, a triple root at x equals 0, okay, that would, if you remember, imply a point of inflection, yeah? And if you're not sure what that is, you go back and revise and you will see what it looks like now anyway. Okay, let's see. So for values less than 0, we can test just x equals negative 1, which is what I did here. Okay, so that's minus 2, brackets minus 1 cubed, brackets minus 1 minus 2. Here we go. Minus 2 times negative 1 cubed, that's going to be a negative answer, right? Because it's minus 1 times minus 1 times minus 1, so that's negative. Negative 2 is negative, so that will give me a positive. And then minus 1 minus 2 is minus 3, so we end up with a positive times a negative, which means that y for values less than 0, okay, remember we're testing x equals negative 1, so y is negative there. So we sketch y below the x-axis. Now remember, there's a triple root at 0. That's why we've got this shape, this point of inflection there. Okay, let's see what's happening between 0 and 2. So because we know there's a triple root there, we expect a positive answer, yeah? Because notice how, if you remember from cubics, just y equals x cubed, right? A point of inflection looks like this, yeah? So we expect a positive answer for x equals 1. If you get something else, obviously you redo it. So that's the beauty of understanding what's happening with the graph, because then you will be able to evaluate your answers. Okay, so let's test x equals 1. Here we go. We get negative 2 times 1 cubed, and then times, that's just positive 1, yeah, minus 2. Okay, so that's a negative times a negative, yeah, which is a positive, which is what we expected. So we get x, at that point, we get, when x is 1, y is 2. Okay, so that's why we went up there. And then, okay, there's an intercept, there's an x-intercept at 2. So we expect the curve, right, to cut through 2 and go down. So for values bigger than 2, we're expecting negative y. Okay, so let's have a look. So I did the testing here with 3. Y is equal to negative 2, and then 3 cubed, so that's going to give me a negative answer, yeah, minus 54, and then times 1, 3 minus 2, so negative 54 times 1 is negative, right, obviously it's not going to be to scale. So when x is 3, y is negative 54, and there you have it. Okay, and notice the coefficient for this one of x to the 4 is negative. And so that's why this kind of looks like a weird looking m. So if the coefficient of x to the 4 is negative, you get an m-like shape. And if the coefficient of x to the 4 is positive, you get a w shape. Okay, there you go.